welcome to my channel. In today's video, we will be solving Chemistry Paper 1C of June 2022. Let's take a look at the first question. It says the diagram shows the electronic configuration of an atom of an element. A. Name the part of the atom that contains the protons and neutrons. We know that is the nucleus. B. Give the number of protons in this atom. The number of protons and electrons are equal in a neutral atom, so here we can just count the number of electrons, which is 11. C. Give the number of the group that contains this element. The group number is the same as the number of electrons in the outermost shell. Here there is one electron in the outermost shell of this atom. D. Give the number of the period that contains this element. The period number is the same as the number of electron shells. So here we have 3 electron shells, and so this element is in period 3. E. Give the charge on the ion formed from this atom. If you look at the diagram, you can see that this atom only needs to lose one electron from its outer shell to gain a full outer shell of electrons. So if it loses one electron, it has one more proton, therefore an overall 1 plus charge. Question 2a. The box shows some changes of state. Here we have boiling, condensation, evaporation, freezing, melting, sublimation. The table lists some physical changes. Complete the table using words from the box to show the change of state for each physical change. First we have water to ice, which is freezing. Steam to water is condensation. Solid wax to liquid wax is melting. And iodine crystals to iodine vapor. Crystals are solid and vapor is a gas, so this is sublimation. B. A student plans to obtain salt crystals from a mixture of salt and sand. The student adds pure water to the mixture to dissolve the salt. Part 1. State 2 things the student could do to make the salt dissolve quickly. For that, we can, number 1, heat the water, and number 2, stir the mixture. Part 2. State what the student should do next to separate the sand from the salt solution. Now the sand is an insoluble solid, and in salt solution the salt has dissolved. So to remove the insoluble solid, we have to filter the mixture. Part 3. Describe how the student can obtain pure dry crystals of salt from the salt solution. So the salt solution is a soluble solid dissolved in a solvent. So for that we have to use the process of crystallization. How we do that is we have to heat the filtrate to evaporate off the water. Once the solution is saturated, leave it to cool so crystals form. Then we filter to obtain the crystals and leave them to dry in a warm place. Question 3. Crude oil is an important source of organic compounds. A. The diagram shows how crude oil can be separated into fractions by fractional distillation. Part 1. State what happens to the crude oil when it is in X. So in part X is where the crude oil enters the fractionating column, and here it is heated and vaporized. Part 2. Give the name of fraction E. It is gasoline. Part 3. Give a use for fraction A. Fraction A is bitumen, and it is used for making roads. B. One of the compounds in fraction D is tridecane C3H28, which can be cracked to form shorter chain hydrocarbons. Part 1. State the catalyst and temperature used in this cracking reaction. So in cracking reactions, we have to use a silica and alumina catalyst. So you can write either one. Temperature we use of 600 to 700 degrees centigrade. Part 2. The equation shows an example of a catalytic cracking reaction. C3H28 cracks to produce C8H18 plus C2H4 plus C3H6. Give 2 reasons why this reaction is important. Number 1. Alkenes are needed to make polymers. And number 2. There is a higher demand of shorter chain hydrocarbons, like for fuels. C. Sulfur is an impurity in crude oil. Explain why this is a problem for the environment. The answer to this is simple. When fuels are burned, sulfur combines with oxygen to form sulfur dioxide. This sulfur dioxide reacts with water in the atmosphere to form sulfuric acid, which causes acid rain. Acid rain damages buildings and harms marine life. Question 4. A student uses the reaction between iron and oxygen to find the percentage of oxygen in air. A diagram shows the apparatus the student uses. A. Part 1. State why the iron powder needs to be wet. Iron needs to react with water and air so it can rust, and this is a rusting reaction. So therefore iron needs to react with water is the answer. Part 2, state the color of the compound formed in the reaction between iron and oxygen. Like I said, this is a rusting reaction, so when iron rusts, it has a red-brown coating. Part 2, give the formula of the compound formed. The compound formed is hydrated iron 3 oxide, and the formula for that is Fe2O3. Explain the advantage of using iron powder rather than pieces of iron. The reaction will be faster as the powder has a larger surface area. B. The syringe in the diagram shows the reading at the end of the experiment. Complete table 1 to show the readings on the syringe. Give both values to the nearest 1 centimeter cube. In this table, they have already given us the change in volume in centimeter cube, which is 65. And as they have stated in the question that the diagram shows the reading at the end of the experiment, if you look back at the diagram, you can see that it shows a reading of 16 centimeter cube. To find the syringe reading at start, we have to add 16 and 65, which gives us 81. C. The student repeats the experiment and obtains a different set of results. Table 2 shows these results. Use the results from table 2 to calculate the percentage by volume of oxygen in the air. In this table, we can see that the volume of air in a conical flask and glass tube is 260 centimeter cubes. Syringe reading at start is 90 and the syringe reading at end is 22. For this calculation, we need to know the change in the volume of air, which we can find by subtracting 90 and 22, which gives us 68. We also need to know the total volume of air at the beginning, and that is the total volume that was in the conical flask, glass tube, as well as a syringe. So for that, we need to add 260 plus 90, which gives us 350. So we will multiply 68 and 100, and we will divide by 350, which gives us a value of 19.4%. Question 5. This question is about alkanes and alkenes. A. The alkane C5H12 has 3 isomers. Part 1. State what is meant by the term isomers. The definition of isomers is simple. I'm sure you have read it in your book. Molecules with the same molecular formula but different structural formula. Part 2. Calculate the relative formula mass MR of C5H12. We have 5 atoms of carbon and 12 atoms of hydrogen, and we know the AR of carbon is 12 and the AR of hydrogen is 1. If you don't know, you could look at the periodic table that we have at the beginning of the paper. So how we have to find the MR is 12 multiplied by 5 plus 1 multiplied by 12 is equals to 72. Part 3. This is the displayed formula of one of the isomers. Give the name of this isomer. There are 5 carbon atoms, so we will use the prefix pent, and since there are all single bonds between the carbon atoms, so we know that it's an alkane, therefore we use the suffix ane, so this is pentane. Part 4. Draw the displayed formula of the other 2 isomers. Here are the isomers. B. Ethane C2H6 and ethene C2H4 both react with bromine. Describe the differences in the reactions of ethane and ethene with bromine. Refer to the conditions, the products, and the types of reaction involved. We know that ethane is an alkane, as is evident from the ending ane. We know that alkanes react with halogens in substitution reactions, and these reactions can only occur in the presence of ultraviolet radiation. This reaction forms bromoethane and hydrogen bromide, and ethene is an alkene, as we can see from the ending ene. Alkenes can easily add bromines. This is an addition reaction, and there is no need for any specific conditions, and this forms 1,2-dibromoethane. Therefore, the answer is bromine reacts with ethane in a substitution reaction to form bromoethane C2H5Br and hydrogen bromide HBr. This reaction occurs in the presence of ultraviolet radiation. Bromine reacts with ethene in an addition reaction to form 1,2-dibromoethane. There is no need for light, heat, or any catalyst in this reaction. Question 6. A student uses this apparatus to investigate the reaction between magnesium and dilute hydrochloric acid. A. The word equation for the reaction is magnesium plus hydrochloric acid produces magnesium chloride plus hydrogen. Part 1. Complete the chemical equation for this reaction. In this question, they have already shown us Mg plus 2HCl. The Mg displaces the hydrogen in HCl, so it forms MgCl. But magnesium atom needs to lose 2 outer shell electrons to gain a full outer shell of electrons. Meanwhile, a chlorine atom needs to gain 1 electron to get a full outer shell of electrons. Since there is 2 molecules of HCl, therefore there are 2 molecules of chlorine. So the 2 electrons that the Mg atom loses, each atom of chlorine gains 1 of these electrons, and therefore it forms MgCl2 plus H2. Part 2, give the test for hydrogen. This is a simple question. You must have learned this in the chemical test chapter. It gives a squeaky pop when ignited. Part 3, the student uses 0.090 gram of magnesium and 0.025 moles of hydrochloric acid. Show by calculation that the hydrochloric acid is in excess. First, we need to find the moles of magnesium. The formula for moles is number of moles is equals to mass over mR. The mass of magnesium is 0.090 gram and the mR of magnesium is 24. When we divide 0.090 and 24, we get 0.00375 moles of magnesium. If we look at the equation, we can see that 1 mole of magnesium reacts with 2 moles of hydrochloric acid. Therefore, we need to multiply 0.00375 moles of magnesium by 2 to know how many moles of hydrochloric acid are needed. This shows us that 0.0075 moles of hydrochloric acid should react, but since the hydrochloric acid is present in 0.025 moles, therefore it is in excess. B. The student measures the volume of hydrogen collected at regular intervals until the reaction stops. The table shows the student's results. Part 1, plot the student's results. They have already provided us with a graph which has both of the axes already labeled, so we just have to look at the table and plot the values accordingly. As we can see from the table, the time values should be placed on the x-axis and the volume value should go on the y-axis. First we have 0, 0. Next we have a time value of 15 and a volume of 40. So 50 should be seen from the x-axis and the 40 from the y-axis, so that's where it should be placed. In the same way, we will plot all the other values. We have 30, 68, 45, 80, 60, 88 and 75, 88. Part 2, draw a curve of best fit. Part 3, determine the volume of hydrogen collected in the first 10 seconds. Show on the graph how you obtained your answer. Now you look at the graph line and the 10-second mark right here. If we can place it on the graph, we can see that it gives a value of 26 centimeter cubes. Part 4, explain why the rate of reaction is greatest at the start of the reaction. At the start of the reaction, we have the maximum concentration of magnesium. What that means is that we have the maximum or the most number of magnesium atoms in the beginning. As the reaction progresses, after collisions, there are fewer and fewer magnesium atoms. Therefore, the rate of reaction decreases. So in the beginning, since there are more particles, so there are more frequent collisions which have energy equal to or greater than the activation energy. So the answer is there is a greater concentration of magnesium, so there are more frequent successful collisions. C. The student repeats the experiment at a temperature 5 degrees centigrade higher than the original temperature. All of the conditions are kept the same. Part 1. On the grid, draw the curve you would expect the student to obtain. We know that an increase in temperature gives a faster rate of reaction because particles have more kinetic energy when the temperature is higher, so they collide more frequently. A faster rate of reaction means that the graph should be steeper initially. The second thing to note is that the only thing being changed is the temperature. Nothing else is being changed. So that means that the same volume of hydrogen will be produced. This means that the graph should level off at the same point as the previous graph. Part 2. Explain in terms of particle collision theory how increasing the temperature affects the rate of reaction. Like I just stated, increasing the temperature increases the rate of reaction. How that happens is that particles gain more kinetic energy, so they move faster. Therefore, they collide with each other more frequently, and more collisions have energy that is equal or greater than the activation energy. So we will write this as increasing the temperature gives particle more kinetic energy. As a result, there are more frequent successful collisions, and more collisions have energy equal to or greater than the activation energy. Hence, the rate of reaction increases. Question 7. This question is about copper and copper compounds. A. A sample of copper contains two isotopes, Cu63 with relative abundance 69.5%, Cu65 with relative abundance 30.5%. Part 1. State what is meant by the term isotopes. This is a simple textbook definition. Atoms of the same element with the same number of protons but different number of neutrons. Part 2. Calculate the relative atomic mass AR of this sample of copper. Give your answer to three significant figures. Firstly, we have to multiply the relative abundance of each isotope by its mass number. So first we will do 63 multiplied by 69.5 and 65 multiplied by 30.5. Then we will add both of these values and divide by 100 like so, which gives us a value of 63.6. B. When copper 2 carbonate is heated, copper 2 oxide and carbon dioxide are formed. Part 1. What is the name of this type of reaction? This is a thermal decomposition reaction. So the answer is A. Decomposition. Part 2. Which color change occurs during this reaction? Copper 2 carbonate is a green solid and copper 2 oxide is a black solid. So the answer is C. Green to black. C. A student uses this apparatus to find the value of X in the formula CuSO4 XH2O. This is the formula of the hydrated salt, hydrated copper 2 sulfate, and this experiment is being carried out to calculate the water of crystallization. This is the student's method. Find the mass of an empty boiling tube. Add hydrated copper 2 sulfate to the tube and record the new mass. Heat the hydrated copper 2 sulfate until it changes color. Allow the tube to cool and record the mass again. The table shows the students' results. Part 1. Calculate the mass of CuSO4 formed. They are asking us to find the mass of CuSO4 that was obtained at the end of the experiment. So let's look at the table. First, they recorded the mass of the empty tube, which had none of the reactants in it. Next, they recorded the mass of the tube after the hydrated copper 2 sulfate was added to it. After the reaction had been finished, they recorded the mass of the tube which had only CuSO4 remaining in it. The water had been heated and removed. So for this part of the question, we will subtract the mass of empty tube from the mass of tube and CuSO4. So that gives us 28.20 minus 20.52. It shows us that the mass of CuSO4 formed was 7.68 grams. Part 2. Calculate the mass of water formed. For this, we will subtract the mass of tube and CuSO4 from the mass of tube and the hydrated copper 2 sulfate. This is because the value of 31.77 grams was when the salt had water of crystallization, and the value of 28.20 is after the water of crystallization has been removed from the salt. So when we subtract the two, we will know how much water was formed. So 31.77 minus 28.20 gives a value of 3.57 grams. Part 3. Show that the value of X is approximately 4, MR of CuSO4 159.5 and MR of H2O 18. For this, we will first find the moles of CuSO4 and H2O. The formula for moles is number of moles is equals to mass over MR. We already calculated the mass of CuSO4 and water in the above parts of the question, and they have provided us with the MR of CuSO4 and H2O in the question. So we just have to substitute those into the moles equation. So for the moles of CuSO4, we will divide 7.68 grams by 159.5, which gives us a value of 0.0482 moles. Next, we will find the moles of H2O. For that, we will divide 3.57 grams by 18, giving us a value of 0.198 moles. Now to find the value of X, we will divide the larger of the two mole values by the smaller mole value. So in this case, we will divide 0.198 by 0.0482 moles, giving us a value of 4, and that's the end of that question. Part 4. The actual value of X is 5. Give a reason why the calculated value of X is lower than the actual value. A common error in this experiment is that not all of the water is removed. Question 8. Diamond and graphite are giant covalent structures made of carbon atoms. The diagram shows their structures. A. Discuss the differences between diamond and graphite. This is a 6-mark question, so they are asking for 6 valid points and the answer should be in depth. Refer to structure and bonding, electrical conductivity and hardness in your answer. Firstly, let's discuss their structure and bonding and how their structure and bonding contributes to their hardness and electrical conductivity. In diamond, each carbon atom is bonded to 4 other carbon atoms, which forms a giant tetrahedral structure. Therefore, diamond is very hard, and since there are no free electrons in a diamond, so it cannot conduct electricity. However, in graphite, each carbon atom is bonded to 3 other carbon atoms, which forms a hexagonal structure, which is arranged in layers. The layers can easily slide over each other, which is why graphite is soft. And since the carbon atoms are only bonded to 3 other carbon atoms, this leaves free electrons which can jump between the layers, which is why graphite can conduct electricity. We can write this as, in diamond, each carbon atom is bonded to 4 other carbon atoms in a tetrahedral structure, hence it is very hard. In graphite, each carbon atom is bonded to 3 other carbon atoms, forming a hexagonal structure that is arranged in layers. The layers can slide over each other, hence graphite is soft. There are no free electrons in diamond, so it cannot conduct electricity. There are delocalized electrons in graphite which can move around, so it can conduct electricity. B. C60 fullerene is a simple molecular substance made of 60 carbon atoms. The diagram shows its structure. The table shows the approximate melting points of diamond, graphite, and C60 fullerene. Diamond has a very high melting point of 4000 degrees centigrade. Graphite has a slightly lower melting point of 3600 degrees centigrade. And C60 fullerene has a much lower melting point of 600 degrees centigrade. Explain why C60 fullerene has a much lower melting point than diamond and graphite. The answer to this is, diamond and graphite have many strong covalent bonds between atoms and a large amount of energy is needed to overcome the covalent bonds. C60 fullerene has weak intermolecular forces of attraction and much less energy is needed to overcome these. Question 9. This question is about the oxides of lead. A. Yellow lead oxide PbO can be reacted with hydrogen to produce lead. Part 1. Complete the equation for the reaction by adding the missing state symbols. Solid lead oxide will react with H2 gas to form solid lead and water vapors. Water vapor is a gas, so we will write G. Part 2. What is the charge on the lead ion in PbO? We don't know the charge of the lead ion, but we do know the charge on the oxygen ion must be O2 minus. And we also know that the same positive charge should be on the metal ion to balance out the charges. Therefore, since oxygen has a O2 minus charge, Pb must have a Pb2 plus charge. So the answer is D. Part 3. Explain why the reaction of yellow lead oxide with hydrogen is a redox reaction. Lead oxide is reduced as it loses oxygen. Hydrogen is oxidized as it gains oxygen. Part 4. Describe a physical test to show that the water produced in this reaction is pure. Measure the boiling point. The boiling point of pure water is 100 degrees centigrade. You must keep in mind that when there is an impurity present in a substance, it can change the melting and boiling point of that substance. B. When red lead oxide Pb3O4 is heated, yellow lead oxide forms. The equation for the reaction is 2 Pb3O4 produces 6 PbO plus O2. A scientist heats a known mass of red lead oxide in a crucible in a fume cupboard. The scientist leaves the crucible to cool, then records the total mass of the crucible and its contents. Part 1. Describe what the scientist should do next to make sure that all the red lead oxide has reacted. For this, the scientist should heat, cool, and record the mass of the crucible and its contents again and again until the mass is constant. We can simply write this as heat to constant mass. Part 2. The red lead oxide used in the reaction has a mass of 5.48 grams. Calculate the maximum mass of yellow lead oxide that could form. Mr of Pb3O4 is equal to 685. Mr of PbO is equal to 223. First, we will find the moles of Pb3O4 by dividing the mass 5.48 grams by its Mr 685, giving us a value of 0.008 moles. Now we will find the moles of PbO. For that, we have to refer back to the equation. Looking at the coefficients, we can see that 2 moles of Pb3O4 produces 6 moles of PbO. So the molar ratio is 2:6, which after simplifying is the molar ratio of 1:3. So for the moles of PbO, we will multiply 0.008 by 3, which gives us a value of 0.024 moles. And to find the mass of PbO, we will rearrange the mole equation. So the equation is number of moles is equals to mass over mR. For mass, it will be mass is equals to moles multiplied by mR. So we will multiply 0.024 moles by 223, giving us a mass of 5.35 grams. Question 10. This question is about ammonia and ammonium compounds. A. Ammonia NH3 is a simple covalent molecule. Draw a dot and cross diagram to show the bonding in a molecule of ammonia. Nitrogen is in group 5 of the periodic table, which means it has 5 electrons in its outermost shell. It needs 3 more electrons to have a full outer shell. Meanwhile, hydrogen needs 1 more electron to get a full outer shell of electrons. Therefore, as we can see from the formula NH3, the nitrogen atom forms 3 covalent bonds with 3 hydrogen atoms. And there is also a lone pair of electrons on the nitrogen atom. This is how it should look. I'm using dots to represent the electrons of the nitrogen and crosses to represent the electrons of the hydrogen atoms. B. The table shows the names and formula of some ammonium compounds. Part 1. Complete the table by giving the missing information. We have an example here. For the first column, they have given us the name of the compound ammonium sulfate with the formula NH42SO4. Similarly, we have to write the name of the compound with the formula NH4Cl. NH4 tells us that it's an ammonium compound, and the Cl tells us that there's a chlorine ion. And since it's only written as Cl, there is nothing else joined to it, we will write with the ending IDE, so it will be ammonium chloride. We should always keep in mind the difference between the ATE and IDE endings. A simple ending with IDE like chloride means it's only a chlorine ion joined, there's nothing else, and an ATE ending, for example chlorate, means there is something else joined for it, for instance oxygen. In this case, the formula NH4Cl tells us that only ammonia and chlorine are bonded together. Next, they are asking us to find the formula of the compound with the name ammonium carbonate. The simplest way to do this is to just swap over the numbers in their charges. You should remember that the ammonium ion has a NH4 plus charge and a carbonate ion has a CO3 2 minus charge. Now we will cross over the numbers in their charges. The 1 from the NH4 plus ion will be given to CO3, and the 2 from the CO3 2 minus ion will be given to NH4. This means that to have equal numbers of positive and negative charges, you would need to have 2 ammonium ions and 1 carbonate ion. So firstly we will place the NH4 in brackets and write the 2 after it, and then we will write CO3 in front as we do normally. When ammonia reacts with sulfuric acid, ammonium sulfate is formed. Write a chemical equation for this reaction. You should know the formula for each of these. Ammonia is NH3, sulfuric acid is H2SO4, and as we found in the last part, ammonium sulfate is NH42SO4. We will write this as NH3 plus H2SO4 produces NH42SO4. Now we just need to balance out the equation. I have found that the simplest way to balance out equation is to go in a specific order. So first balance out the hydrogens, then the oxygen, then the metal, and then the non-metal. If we add 2 in front of NH3, that gives us 2 multiplied by 3, 6 plus 2, 8 hydrogens. Therefore, the hydrogens are balanced. Moving on to oxygen, we have 4 oxygen on both sides. There aren't any metals, so we will just look at the non-metals. First, let's look at the nitrogens. On the left side, we have 2 nitrogen, and on the right side, we also have 2 nitrogen. Now, as for the sulfur, we have 1 sulfur on both sides of the equation. Therefore, the whole equation is balanced. Part 3. Describe a test for ammonium ions. Once again, you must have learned this in the chemical test chapter of the book. We can simply write this as add sodium hydroxide solution and test the gas given off with damp red litmus paper. Litmus paper turns blue. C. The table gives some information about ammonia and ammonium compounds. Part 1. Calculate the percentage of nitrogen in ammonium nitrate. MR of NH4NO3 is 80. There's actually a very simple equation that you should keep in mind whenever you have questions like such. So whenever you are asked to find the percentage of an element in a compound, you should multiply the relative atomic mass of that element by the number of atoms of that element present in the compound divided by the relative molecular mass of the compound. Then you will multiply whatever value you have obtained by 100. So for this question, the AR of nitrogen is 14, and as you can see from the formula of NH4NO3, there are two nitrogen atoms, one in the ammonia and one in the nitrate. So you will multiply 14 and 2 and divide by the MR of NH4NO3, which is 80. Now you will multiply this by 100 to get the value of 35%. Part 2. Fertilizers add nitrogen to the soil to help plants grow. Ammonia and ammonium sulfate can both be used as fertilizers. Discuss the advantages and disadvantages of using each of these compounds as fertilizers. Use information from the table in your answer. pH of rainwater is approximately 5.6. You can see in the table that there is 82% of nitrogen in ammonia, and ammonia has a pH of 11, which is quite high. Meanwhile, there is 35% nitrogen in ammonium nitrate, but ammonium nitrate has a pH of 5.5, which is very close to the pH of rainwater. So the advantage of using ammonia is that it has a higher percentage of nitrogen. However, it does have a higher pH, so it will cause the soil to become alkaline, and alkaline soil hinders plant growth. On the other hand, ammonium sulfate is easy for plants to absorb because its pH is closer to the pH of rainwater. However, ammonia and ammonium sulfate are both soluble in water, so will run off. And that's the end of the chemistry June 2022 paper 1. I will be solving paper 2 in the next video, so keep a lookout for that. If you have any questions, feel free to ask me in the comments and I will do my best to answer. I hope this video was helpful for you. If it was, give this video a thumbs up, subscribe to my channel and share this video with your friends. Happy studying!